fractions. As if fractions isn't bad enough, we have complex fractions. You know what a complex fraction is? Complex fraction is a fraction that contains fractions within the fraction. For example, the simplest one I can think of would be like, let me do this. A over B over C. Over C. Does that mean the same as the fraction A over B over C? Now I use the word over with a lot of slack there. I probably should have said the fraction A divided by B is divided by C, and I should have said A divided by the fraction B divided by C. You see this one line is longer than the other? That longer line is very important because what this means, what this fraction means is I take A divided by B, and the long line here means divided by, okay? I could write that as divided by what?
C.
C, okay? So I could write that longer line means divided by C. And then what you would have would be A over B, then what? Times 1 over C. Okay? And the answer would be A divided by BC, right? A divided by BC. What if you had it the other way around? What if you had A divided by, this is the way I had it, the other part would be A divided by B over C. Would that mean the same thing? What does that mean? It means I have the fraction A, all right, which is divided by, remember the yellow line means divided by, and then the fraction would be B over C. Now how do you do A divided by B over C?
A times C over B.
A times, this would be inverted, now that would be C over B, and that would give you AC divided by B. AC divided by B. That's not the same as that, is it? In other words, in this A over B over C, A over B over C, it matters which line is longer, doesn't it? It matters which line is longer. All right, now the first few exercises on page 64 and 65 of this one-step book. This is called Intermediate Algebra One Step at a Time. The first couple of pages, you just have, let me take number 10 for example. That's the bad one on the page. Page 65 from the one-step book. And number 10, it says x squared minus 2x minus 3 divided by x cubed plus 1. Then there is a longer line, and then there's another fraction, x squared minus 3x divided by x squared minus x plus 1. Okay, that's the problem. Looks ugly, doesn't it? Looks awful. Actually, now what I want you to do is think about this fraction really represents two fractions. So let's take the numerator, which is in pink, and let's put it right here. And then the long line here means divided by. I've got that in yellow. That means divided by. And then this blue part down here, the denominator fraction, I'm going to take it and put it over here. You see what I'm going to do now? I'm just taking the numerator, putting it here, and that's x squared minus 2x minus 3 divided by x cubed plus 1. I'm taking this denominator and I'm sticking it right here. That's going to be x squared minus 3x divided by x squared minus x plus 1. Okay? Now, you know what you got? You got a problem just like what you did in section 2. Section 2 of the other book. You know, section 6.2, when you multiply and divide fractions, what are you going to have to do before you can multiply and divide these fractions? Factor. Factor, 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 and whoops, you can't factor this one. There's the trick. You can't factor that one. If you try to factor that one, you won't be able to. Okay? Now I think what I should do is probably leave that and let you finish it, right? Can everybody finish that? No? No? Okay, all right, I'll do it quickly. Factor the numerator. I thought I could get by with one, but I can't get away with anything here. What do? Factor that numerator into what times what?
X minus 3.
Minus 3, x plus 1. Good. And how about x cubed plus 1? Is everybody crackerjack on factoring the sum of cubes? Remember we did that last time? What do we start off with? X plus 1, right? X plus 1. Then what? X squared minus x plus 1, right? Okay? And then, do you notice something about that x squared minus x plus 1? I promised you that would never refactor. Didn't I promise you that? What about this x squared minus x? That's the same as that. Did you notice that's the same as that? Ha! Just leave it alone. Don't mess with it. All right, now what? Times. Time. We'll invert multiply. Only you can't factor that, can you? So just put the whole thing down just like it is. X squared minus x plus 1. Don't make the mistake of trying to factor that. And the denominator, can you factor what was the numerator now becomes the denominator. You can factor out an x, and what's left? X minus 3. Now, do you see any factors that divide out? How about the x minus 3 with the x minus 3, right? The x squared minus x plus 1, that whole quantity with this whole quantity, right? Anything else? Oh, x plus 1. That's the most I should have seen that right away. The x plus 1 with the x plus 1. Those are all. Now, what's left in the numerator?
1.
Always a 1. So you get an answer of 1 divided by x. 1 over x will be the answer. Any question on that? Now that's the worst one on the page. Okay, so now let's go on. And beginning on page 66, I'm going to show you, and I think the standard way to teach this is to show two methods, method 1 and method 2. Method 1, in doing complex fractions, follows this pattern. Whatever the numerator fraction is, you take it and you put it down here. Whatever the denominator factor is, you put it here, you put a division sign in between, and you go up. Go at it, okay? You simplify the pink part, you simplify the blue part, and then you treat it as two separate problems, really, and then you invert multiply. The strength of method 1 is it doesn't matter how complicated the problem looks, you only have to look at half of it at a time. So you only have to look at the top part, and then you have to look at the bottom part. Let me do an example of this, method 1. And what I like to do is do number 12 on page 67. Page 67 for method 1, and it says on page 67, number 12, it says x over 5 minus 5 over x. And then this long line means is divided by, and then the denominator is going to be this, 1 plus 5 over x. Okay? Now the way we write this is you just rewrite the numerator right here. Take the numerator and put it right there. X over 5 minus 5 over x, and then divided by, and then the denominator part we'll put right here, 1 plus 5 over x. Okay? Now then, find the common denominator for the blue part. I think I got my colors backwards, didn't I? Sorry about that. I mean, from what I had in the last problem, I was trying to be consistent with my colors throughout the whole evening, but I switched. I now have the numerator blue and the denominator pink. Sorry about that. Nobody noticed, did you? What's the common denominator here?
5x.
5x. What's the fast way to get the numerator? The fast way. X squared, and then minus 25, right? And then divided, now still divided by, right? Still divided by. Divided by. Now we got to get, this is actually 1 over 1, so what's the common denominator here? X. So the product is x, isn't it? So you can do the shortcut, which would be what? X, and then plus 5 divided by x. Any question on that? Okay. And then what? Now it's just like what you did before. Factor, invert, multiply, right? Let's see what you get for an answer. X minus 5, x plus 5, divided by 5x, and then it'll be times, because I'm going to invert multiply now, and I'm going to have this x divided by x plus 5, right? Now, can you reduce anything? Can you divide anything out? The x with the x, because it's 5 times x. See, that x is a factor, and that allows you to divide out the x, in case you were wondering. And how about the x plus 5 with the x plus 5? So the final answer would be x minus 5 divided by 5. Okay? X minus 5 divided by 5. All right? Now, method 2. I'd like to do for method 2, number 15. Number 15, method 2. Do you know something about number 15? It's the same as number 12, isn't it? In fact, did you notice about page 68? Page 68 is exactly the same as 67. It's just method 1, method 2. So I'm going to do number 15, which will actually be the same problem. But I'm going to show you a new method. This is called method 2. Method 2 is sometimes a shortcut. Sometimes a shortcut. Sometimes it's a really good shortcut. Sometimes it's not a good shortcut. Sometimes it's not convenient. And I'll try to explain that to you also. Number 15. Here's the problem. You've got x over 5 minus 5 over x, just like before. It's divided by, and the denominator is 1 plus 5 over x. Okay? Now, what I want to do is find the common denominator for the whole problem, which is, if you took all the fractions and all the denominators, numerator and denominator, what would it be? 5x is the total common denominator. Now, what I'm going to do, I'm going to multiply the numerator and denominator of this by 5x. See, I'm going to multiply the numerator and denominator by the common denominator. Now, if you're taking notes on this problem, let me put in an extra step here to show you exactly what I'm going to do, although I don't usually take time to show this step. If you have to go through this step, it's not worth it. Okay? But I want to show you this step so you'll have something to fall back on. If you're taking notes on this problem, and you know, when you get home, the problem's not done in color. Did you ever notice that? When I do the problem here in class, with all the support of everybody around you in class, it's like learning math in color, and when you get home, the thing looks like it's in black and white. And so anyway, here's what I'm going to do. Distributive property. I'm going to have 5x times this, x over 5. And then I'm going to have to do 5x minus 5x times 5 over x. Okay? That's what I'm going to do. I'm going to do this times this and this times that. That's how I get that numerator. And then it's all divided by. And now for the denominator, I'm going to have to do this times this. That's going to be 5x times what? 1. And then I'm going to have to do 5 plus, see, I got to do 5x times 5 over x. Okay? Now, that's just what I'm doing. I'm taking this times this, this times this, this times this, this times that, and that's what it looks like if you write it down. Now, what I just said is if you have to write it down, it's not worth doing it. Let's just do it. Let me show you how simple this is if you just do it. Now, forget that for now. That's just there in case you need to come back and look at something later. If you get confused when you get home, say, you ever do this? You say, I can't believe this is in my handwriting, but I understood this when I wrote it down in class. And there it is, it's in my handwriting, but I don't know what it means. Well, that's for you. Now, in the meantime, let's just go ahead and do the numerator. What's 5x times x over 5? What does that simplify to? The 5 divides out. What's it give? X squared. You see that? X squared. And 5x times 5 over x, what happens? The x squared divides out. What's left? X divides out, not x squared. I said x squared, didn't I? X divides out, and you're left with minus 25. You see, the numerator simplifies to just x squared minus 25. And then we got a fraction line. You see, you can do that in your head, can't you? You don't have to write that down. That's just for now. All right, now, this is even easier. What's 5x times 1? Gosh. 5x. Boy, that's a tough one, wasn't it? Everybody got that one right? All right, 5x times 5 over x. What happens? The x divides out. What's left? Plus 25. Do you see that? How easy that was? So in that one step, you've eliminated the complex fraction, and now you got a regular fraction to reduce. How do you reduce that regular fraction? By factoring. How do you factor that? X minus 5, x plus 5, and the denominator would be x plus 5, right? Okay? And then what happens? X plus 5 divides out, okay? So the x plus 5 divides out, and the answer is, just like it was before, I hope, x minus 5 over 5. Is that it? X minus 5 over 5. Any questions on that? So not as bad as they look? Now, the thing you're probably wondering, some of you take the attitude, well, don't teach me two ways to do something, just show me one way and let me out of here. Well, the thing about this is this shortcut is so good sometimes, but it's not always convenient. And I've tried to give you a summary at the bottom of page 68 of which problems are going to be convenient to use method 2. If the problem has a very simple common denominator where the numerator and denominator are almost the same common denominator, then method 2 is a good shortcut. But if you've got some ugly common denominator for the numerator and some weird looking different common denominator for the denominator, then forget method 2, just do method 1. Take the first one divided by the second one, okay? And just do it by method 1. You'll have to practice a few of those to really appreciate them. I've given you some clues as to which ones might be good and which ones might be hard. Let me take a look at a problem that involves negative exponents. This usually causes a problem with students. Look at number 38. I'd like to skip over to number 38. By the way, it is unusual that you would have to sit through this much fractions all at once. And usually in a day class, you would have a certain assignment made, and then you have a chance to go do some problems, and then you come back and ask questions. In this class, being a night class like this, you have to sit through the whole thing. Not only all those adding, reducing fractions, adding, subtracting, multiplying, dividing fractions, complex fractions, all this in one sitting. And then we come back next time and see if you have any questions. So this is a difficult way to learn math, but it's the only way we have for the summer. All right? 3x, number 38 on page 72 is the one I'd like to do. 3x, the quantity to the negative 1, plus 3x to the negative 1 divided by, and I meant to use a different color on that. Not very different, but it'll be a little bit different. And divided by x to the negative 1 plus 3 to the negative 1. Okay? Now I've got to show you a couple of things about this. First of all, you remember the wonderful laws of exponents that we had where when you divide, you subtract exponents? You know what? These do not apply here. Because we're not multiplying, we're adding and subtracting. This is this plus this minus that. Those wonderful laws of exponents don't apply here. When you divide, you subtract exponents. When you multiply, you add exponents. Those don't apply here because it's adding and subtracting. Another thing you might remember if you had a negative exponent in the numerator, it can magically end up in the denominator. Guess what? That doesn't apply here either because you're adding and subtracting. In other words, all the good little shortcuts you thought you had in your back pocket on this problem are out the window. We got to go back to basics. In other words, not basic algebra, we've got to go back to basic principles. And what do you do with 3x to the negative 1? What's the one thing you know about 3x to the negative 1? What does that mean? 1 divided by 3x, right? 1 divided by 3x. That's what 1 over 3x, the quantity, means. Now, do you notice that this one has parentheses and this one doesn't? Does that make a difference?
Yes.
Okay, then what this plus sign means, plus, right there, put the plus sign in there, and 3 times x to the negative 1. There's a big difference there because that means only the x's to the negative 1. That means what?
3 divided by x.
Divided by x, right? 3 divided by x. Is that clear? Or 3 over x? 3 divided by x. That takes care of the numerator now, doesn't it? And what's that long line mean? Divided by. Now, how about x to the negative 1? What do we mean by x to the negative 1?
1 divided by x.
1 divided by x. And then we got a plus sign, and then we got a 1 divided by 3. Okay? And you see what we've done? We've gone from negative exponents into complex fractions. It's a complex fraction. It's just like what we were doing on the other pages there. So, method 1 or method 2?
2.
Some folks will say, method 1, always use method 1. Method 1 always works. Don't bother me with method 2. And if you want to do that, that's fine. But in this case, what's the common denominator for the numerator? 3x. What's the common denominator for the denominator? 3x. What would be easier than method 2 on this problem? I think we ought to try method 2. Reach out and try it. 3x times the numerator, 3x times the denominator. You might be surprised at how quickly this thing simplifies. What's the numerator going to be? 3x times 1 over 3x would be? 1. Okay, so we got a 1 for the numerator. And then there's a plus sign right here, okay? See this plus sign? I'm going to do that in a goofy color, purple. Plus, right? That plus sign's going to go right here. That plus sign is that plus sign, right? And then what? 3x times 3 over x. What happens? X divides out. What's left? 9. Okay? Any question on that? Now you see this fraction line right here? That fraction line is going to go right there. That's the same fraction line. Now, what do we do for the denominator? 3x times 1 over x. What happens? The x divides out. You're left with 3 in the first position. Okay? Now, I got this plus sign right here, right? This plus sign is going to be this plus sign, right? Okay? And now what? 3x times 1 over 3. What happens? The 3's divide out. What's left? X. The 3's divide out. All that's left is just the x. Now, can you simplify that expression? What's the numerator? 10. Okay, big deal. 10. And the denominator is? 3 plus x. Okay, and that's the answer. Any questions on that? Wasn't as bad as it looked, was it? Okay? Wasn't as bad as it looked. I hope it wasn't as bad as it looked. I like problems when they are not as bad as they look. Okay? All right, next problem I'd like to do is turn over another page. And one like number, 53. No, 52. Let's do 52 on page 74. And it says the quantity of 3x to the negative 1 plus 3y to the negative 1, all raised to the negative 1. How's that look? Remember that law of exponents says if you have a power raised to a power, you just multiply exponents? You think that works here? Nope. It was a good law, but it only applies when you have products and quotients. If you have a sum raised to a power, in other words, this plus sign right here, because that plus sign, you can't just raise to the power and multiply exponents. That property is only for products and quotients. So again, what I'm going to have to do is just keep this whole thing as a fraction to the negative 1 power. Let's keep the negative 1 power, because I know what to do with a fraction to the negative 1 power. What do you do with a fraction to the negative 1 power? Remember how to do that? Just invert the fraction, right? So can you get this to be a fraction? What would be 3x to the negative 1? What does that mean? 1 over 3x. Right now, plus. This plus sign, let's do it in a different color so it'll stand out. Plus. And then this 3y to the negative 1, what would that be? 1 over 3y. Okay, and the whole thing is still all raised to the negative 1 power. Now, what we said is if you have a fraction to the negative 1 power, you invert it. Do I have a fraction to a negative 1 power? I don't have a fraction. I got two fractions. Did anybody say anything about inverting two fractions? You're not allowed to. Nobody ever said that I remember. Unless you're making up your own rule, you can't do that. So we have to get a single fraction before you can invert multiply. What are you going to have to do before you get a single fraction? Common denominator. You've got to add these two together. So what is the common denominator?
3xy.
3xy. Okay? Now you can't do this shortcut, can you? Because that shortcut only applies when it's the product of the denominators, you see, that makes the common denominator. What we have to do is go back and play what's missing. So compare this to this and tell me what's missing. Y. So we'll multiply by y over y, right? What's missing in the second one? x. So we'll multiply by x over x, is that right? So now, the common denominator is 3xy, and the numerator is y plus x, okay? Y plus x. I didn't do it in color for you. Y plus x. And that whole fraction, now we still got that whole fraction raised to the negative 1 power, okay? That whole fraction is still raised to the negative 1 power, right? Now, what can you do when you have a fraction raised to the negative 1 power? Invert the fraction, right? And so the final answer now is going to be, give me the final answer with a drum roll. What's it going to be? 3xy divided by y plus x. And that'll do it. Okay? Any question on that? All right.
It's not on that, but on the homework, you only go to page 71. Did you want us to go to 74?
Yes. Did I say go through 71? Oh, I didn't realize I had stopped you on 71. That's an error on the assignment sheet. Thank you for catching that. I want you to go through 74. Yes. Go through 74, please. Make that correction on your assignment sheet. I don't know where I got 71. I have never stopped at page 71. That has to be a typographical error. All right? Now, there are 2 more topics, and I only have 2 minutes left in the class, so I'll have to be brief. Do I know how to do that? My wife would be laughing about that one if she heard that one. I'm going to be brief. Yeah, right. Okay. Now, I think probably, let's take a look at page 136 to 139 in the one-step book. Page 136 to 139. And I believe I'll try to ask you to get started on that. Then what I'm going to do is I'm going to cover what I can do in about 3 to 5 minutes, and then ask you to just go ahead and try to finish that. Anything you have trouble with on that assignment, we'll just dump it into the assignment for the next time, which is for the test the following time. And then we'll just catch up with everything